All right, look how complicated example 7 is. We have a quadratic over a cubic, and notice that still it's of the form a du over u, which is indicating to us that, hey, we're probably going to try some partial fraction decomposition, especially if the derivative of the bottom does not exactly match up with the top, and I don't think that it would, right? So if u is equal to 2x cubed plus 3x squared minus 2x, you take its derivative, du is equal to 6x squared plus 6x minus 2, and like we could factor out, oh yeah, dx, I forgot about that. We could factor out, let's say, a 2 from all this, but even so, it does not match up with what we have on the top. Okay, again, all of these things are signs pointing us towards partial fraction decomposition. Okay, so remember, next step is to factor. How do you factor a cubic? Well, hey, in this case, it's very nice that everything shares a common factor of x in it, so that we can pull that out. X times, then I have 2x cubed, no, squared, no, 3x, and then minus 2, and what we have left over is quadratic, which we should be able to factor. Let's see. Open these things up, or just guess and check it. I know that this is probably a 2x and an x, and then for the last two spots here, we got to multiply up to a negative 2. I'm not going to put the 2 in that one. It's got to be in this one if it's going to work. And then let's see, we have an x and we have a 4x. That would work, especially if, let's say that this one is positive and this one is negative. We're good to go. All right, it's all nice and factored. So I am going to write this. Now notice I've got 3 factors here. I've got 3 factors. So whenever I rewrite this as an x squared plus 2x minus 1 over this new factored denominator, I need a linear factor for each one of these, meaning I need an a, b, and a c this time. A over x plus b over 2x minus 1, and then c over x plus 2. Okay, quickly running out of space, so let's just zoom this right down here. All right, and of course, the next step is to multiply by least common denominator. You don't have to write all of this down. You can go straight to the answer, especially after you've done a few, you know exactly what to expect. And when I do, all I'm left with is the quadratic for the top on the left-hand side. And then on the right-hand side, only the x is going to cancel out for the a term, but we're still left with these two factors, x squared minus 1 and the x plus 2 for the a. Okay, and for the b term, the 2x minus 1 will cancel out, but it still leaves a factor of x and x plus 2. And then, excuse me, finally, for the c, the x plus 2's will cancel, leaving these two factors, x and 2x minus 1. Now you can see this is a lot more complicated basic equation than we've seen in the past couple of examples, which means we've got 2 options here. We can choose some convenient values, just like we did before, to make either the a or the b or the c to disappear, or expand all of these things out, combine some like terms, and then equate the coefficients, 1 in front of the x squared, 2 in front of the x, and negative 1 for the constant, and then just throw it all into a matrix and be happy with it. Let's just do the little basic equation by picking some convenient values, and watch what's going to happen. Notice that if I choose x is equal to 0, it's going to cancel out the c term, and it's going to cancel out the b term, leaving me with just the a term, which is really convenient, right? So I'll get rid of 2 of these things for the price of 1 convenient x value. So here we're going to do x is equal to 0, and we will have 0 squared plus 2 times 0 minus 1. Of course, you didn't have to write all that down. You could have written just negative 1. And then a times 2 times 0 minus 1 and 0 plus 2. Not going to bother with the other ones because that's 0, the whole thing's gone. That's 0, that whole thing is gone. Just clean this thing up a little bit. -1 is equal to, here this is going to get -1. This one's a 2, so it's a -2a, meaning that a is equal to a positive 1/2. All right, 1/3 of the way done. Now we have to choose another convenient value to make something else disappear. The next easiest one is this factor here. So if I choose x is equal to -2, this will be gone, this will be gone, and it'll leave me with the c term. So that's next. X equals -2. Everywhere. Plug in -2 for your x. So plugging in -2 here makes this a 4 minus 4 minus 1. Hey, that's super convenient. Is equal to, this whole term is gone. This whole term is gone. All I'm going to do is worry about the c. c times a -2. That looks like a 1. Now it looks like a 2. 2 times -2 is a -4 minus 1. All right, now let's simplify here. The 4's are gone. I'm just left with a -1 is equal to, here's a -5 times the -2 gives me a 10c, meaning that c is equal to -1/10. Hooray. All right, we've got another one. And then lastly, what are we going to choose so that we can get the b? We have the a, we have the c. We need to get the b term. The other two have a factor of 2x minus 1 in it, which means that that's the one that I need to make disappear. What is the value of x that we're going to choose? It's going to be positive 1/2. X equals 1/2. All right, and then again, that will cancel out these two terms. We won't have to worry about it. We'll just have to plug in our 1/2 here and our 1/2 over on the left-hand side. This one is definitely the most challenging. 1/2 squared is 1/4, plus 2 times 1/2 is 1 minus 1. Hey, that's also convenient, is equal to, this term is gone, that term's gone. It's just the b term. B times 1/2 times 1/2 plus 2. Now I just have to clean it up. Left side, we're only left with 1/4 is equal to b times, So 2, that is a 4/2, makes this 5/2. Multiply that times 1/2, and I get 5/4. All right, and this means that b is equal to a 1/5, I think. Here, I'm just going to multiply by the reciprocal. 4 over 5. 4's cancel. Yeah, it's a 1/5. Oops. B is equal to positive 1/5. All right, now the algebra side of this is done. Let's get to the calculus and rewrite. Make sure you're paying attention to the order of all of your partial fractions. The a, which was 1/2, was on top of the factor of just x. Your b, which is 1/5, was on top of the factor of 2x minus 1. And then finally c was negative, I think, so -1/10 over x plus 2, was it? Yes, it was, dx. All right, now the only one that looks like we're going to have to fix is this one here, because this one is just straightforward natural log. This one is also almost straightforward natural log. U is equal to x plus 2, so du is equal to just dx. There's nothing to fix. All right, so nothing to do there. But this one, however, u is equal to 2x minus 1. Du is equal to 2 dx. So for just this one part, let me just do this over here so we can see what to expect. I'm going to pull the 1/5 out, the original 1/5. It doesn't gunk up everything. And we need to fix this with, so right now it is what, a 1 basically over 2x minus 1 dx. We need to force in a 2. I'll force in a times 2 and compensate with a 1/2. So you can see that on the outside of this, we're going to end up with a 1/10. And then we're good to do our U substitution and natural log business. Okay, all right, there we go. So term by term, we have 1/2 natural log absolute value of x plus, whenever we multiply these together, 1/10 natural log absolute value of 2x minus 1. And then finally, minus 1/10 natural log absolute value of x plus 2. Throw in a plus c, and you're pretty much done. Is it possible that you would have to combine those things up? Sure, right? These two would be multiplied together with these exponents there, and the whole thing would be over this denominator.